Good evening, one and all. It's my immense pleasure to invite you to the second day of Unfold 0.2 expert talk. Unfold 0.2 is a design competition that explores the possibility of parametric design technologies. Through this design competition, we envisage the combining of new digital design and fabrication technologies with traditional hands-on building techniques that will help designers gain more insight into the strengths and weaknesses of their designs. This design and build competition is to encourage parametric design ideation and digital fabrication that can lead to exciting new design possibilities in architecture. A forum where architecture students and professionals can research and experiment using cutting edge technology with an agenda to endure until design transforms into reality. The entrants are expected to deliver a futuristic design proposal of an architectural element that enhances a space. This competition is a brainchild of architect Leela Krishnamurthy sir and his team from Folds Design Studio, Mumbai. Architect Leela Krishnamurthy sir is an architect based from Mumbai with more than 2 decades of architectural design experience. He currently runs a successful design plus workshop studio called the Folds Design Studio in Mumbai. They work on parametric designs that are innovative and cutting edge in today's time. Folds is an exclusive design studio that is passionate in bringing ideas to life, where art and technology are interconnected to design and produce. This is the innovative platform where ideas are unfolded through virtual graphics to achieve constructional designs. They aim towards connecting the processes of design and manufacturing. I would like to invite architect Krishna sir to elaborate on this design brief and as well as talk about some of the materials and other things that we should be working on through this Unfold competition. Welcome, sir.
Yeah, good evening, Prithvi.
Good evening, sir.
And good evening, all. So this design competition that we have come out with is for all the students and the professional architects who are practicing in India. So the idea is to promote parametric architecture in a big way. That's one thing. Second, it is also for you to understand how parametric architecture is not only designed on softwares, but they can also be built through certain kind of a technology which can be used out here. So what I will do is quickly I'll try and present few slides through which you can understand how materials can be taken care of, how a design can be thought about first, and second, how to select materials, and third, how to execute. Okay, so quickly I'll start with the presentation. Yeah. So this is something where I would like to tell you about how a facade can be treated. And even if you get a big scale facade, how small elements can be a part of your design and how they can be explored in a big way. One. Where is this? Is it on full screen?
Sir, you will have to stop the screen share and share again. Share the full screen tab.
Okay, 1 minute. I'll do that. Share. So you're in it now? Yeah. Okay. Done. So this is I'm sorry. So this is for you to understand how a small material or a local material like brick can be used as a pattern and it can become a facade treatment. So, so brick has been divided into multiple parts for you to understand and how it can become a facade treatment. So, a small piece of a brick can be sliced into multiple layers and it can also be designed in detail in such a way that it can also act vertical as well as horizontal. So this is a kind of a process. That you can look into, and just for you to understand how these kind of bricks can be converted. I mean, solid bricks can be converted into slices, for which you need tools. The tools that could be machines. That is something which you need to understand. So the facade can become like this on a larger scale. So when you see it from inside, the same thing can get converted into something like different kind of a patterns, which can be created through light. So the building, the material that we are trying to use on the facade can create these kind of patterns inside. So, the idea for you, if you're designing this as a product and considering this to be a part of a facade, then these are the treatments that you need to actually look into. So I'm just giving you an example of a brick, but it can be anything. So that's how the elevation can become, if it is large facade, but with small elements. Let us say the design is about 8 feet by 8 feet. So even if you take a 8 feet by 8 feet square and design something like this, it could literally enhance a facade, and it can be multiplied into different patterns. So also if you are entering into interior spaces where you can derive your details and concepts from, they can be derived from nature. So, which are surrounding you. So you can literally copy things from nature and try to create different kind of designs, which can be a part of your interiors. So, quickly you can convert those designs, those patterns, those details that you have tried to copy from nature. They can be converted into your design patterns in 3D models, and they can be 3D printed as well, so that we can understand how they can be built in interior spaces. Whether it is small or large, that doesn't matter at all. Then you need to make your paper models just to understand whether these kind of designs are feasible or not. So at large, how can they be designed and built is something which you need to understand. So a product can be at large at this thing, or it can be also a small installation. So your art installation, if you're designing the details in such a way that they can be as small as 8 feet by 8 feet, or it could be just 2 feet by 2 feet also, but it can be somewhere around 400 feet by 300 feet as well. So these large installations can also be designed thinking and understanding with a different context. Okay, just for you to understand how small benches can be designed. These are around 40 feet long design. Long benches, which are also sculptural pieces in interior spaces. Yeah. So a material, how to select a material, what material is necessary for you to understand how they can become your final element is something which you need to cater to. So look at the benches, they're also sculptural pieces, and they're also a furniture piece, and they're part of a space, a large space. So these are different kind of benches that we have designed. So another seating space, a small seating space which is just 10 feet by 10 feet by 8 feet. A module can be detailed out, and such kind of a designs can also be a part of your interiors. It's something which we need to understand. A sofa like this of a different shape and a different nature, which is just made out of concrete. So a specific material has been used out here to design this space. And also you need to understand that these kind of microbot kind of a design detail can also be executed for a different kind of a purpose. In this case, we have designed a lift information iPad, basically considering a lift information iPad and converting that into a lift information bot. So what we have done is we have designed this kind of a bot, which is a floating bot, basically, and incorporated the iPad through which the information can be sent to the lifts, so that the lift comes down, and then you understand which lift you can take up and go into this space. So this is a different kind of a lift bot that we have designed. So you can also think of these kind of products. So these products can also be a part of a larger space. So this is something which you need to understand when you're designing, or probably trying to understand what kind of a subject you want to actually take into while participating in the competition. So this is how your designs can evolve, and they can become smart objects inside the space. So similarly, a different kind of a dining table is something which we have designed out here. We are just trying to showcase some products for you to understand how you can inspire yourself and be a part of this competition and make sure that you give something really good. So this is a design which we have derived from stone pieces, not from a solid stone block. So that's how it looks like. So again, I mean, from a table to a column. So again, we are trying to deal with the scale. So this is a 30-feet column which has been designed with a fluidic pattern. So multiple 3D printed models have been derived first, just to understand whether the scale is perfect or not. Then we 3D printed the whole sculpture, the whole column, which is actually a sculpture on the building. Just trying to get new material in place, which is a concrete block, small Ciporex concrete blocks. They can be cut with these CNC machines and new details can be derived. So you know how they can be executed. So basically from design to 3D printing to detailing and to execution. The whole process is something which I'm trying to explain to you so that it becomes much easy for you to participate into this competition. So that's how the columns can be derived from a 3D generated model till execution. So there is a complete process behind it. So this is how your elevations can become. A futuristic elevations can be designed. Futuristic different kind of columns can be detailed out. And also, if let us say we are dealing with interior space. In an interior space, certain things like washrooms, they can also be sculptural details. The oval piece you are seeing behind, this is actually a washroom. So we wanted a certain kind of a design which can be incorporated into a space, which also becomes like a sculptural piece. So your requirement basically is a washroom, but that itself is like a sculptural piece in a space of a room. So that's how the whole design was detailed out. Then we did this with using concrete blocks. We have carved them out with CNC machines for you to understand how CNC machines can also be operated, and for you to understand how details can be, converted from or probably transferred from your 3D drawings to execution. So that's how they have been put up on site. Also giving structural strength to them by inserting small rods into it, by drilling holes and then putting small rods into it. And you can achieve your design details to that extent from a 3D model to the site. These are simple things that I'm trying to show you and tell you that how small a product could be, what it could be in a space. It's not only necessary that it has to be a bed or a column or a facade or a washroom. There are multiple things that you can think about. So, the whole idea of this competition is to open up your brains and think and select those areas so that, they become a part as a functional piece inside a space. So this is a bed. So still you have fluidic designs and it can be converted into a bed. So these are 3D generated models. So these could be 3D printed using technology, or you can also CNC it out, or you can also carve this in stone. So the material is something which you need to look into and then convert them into designs. So this is again a 3D printed column that we have done, which is just 8 foot by 8 foot. So, this is a very simple example for you to understand how you can, participate in the competition by understanding the brief basically. So that was a sketch that was done. Then your 3D G codes were converted. 3D printing to the 3D model that you're seeing out here as a sculpture. So that's a design that we created in a software. And then this is something what you are trying to see when it is getting executed, and then the final product. So this is again a 3D model which is converted into art sculpture. So a sculptural design has been 3D printed first. This is a process. So every design that is going to come here to folds through this competition. So you have to explain this process as well. If you explain this process, it will be very easy for us and the jurors to make sure that your designs can be converted into execution details. So that is something which you need to also look into while presenting your slides. Okay. So when a design comes at this stage, it can be converted into this kind of a construction process. A method can be evolved. Then a final product can also be shown, which can be presented. So these are multiple things that I'm just trying to brush you through for you to just understand how designs can be converted into construction. What are the different stages? What are the different kind of materials? Here we have used terrazzo as a final product to get this project done. So again, this is like a 6 tons of a project, but again, in a precise shape, which could be carried which could be transported from Mumbai to Silvassa. A different kind where electronics is used out here to convert your design into a sculptural piece, and also using some mechanical and electrical to convert that into a clock. So such kind of designs can also be derived. And also some benches which we design for airports. So such kind of details can also be produced. I'm just trying to tell you that how you can, think probably what should your approach towards the design should be for the competition. So these are new products that I'm trying to tell you how they can be made, how they can be derived. If it is a staircase, then how? What is the process? What kind of designs can it could be? Then small products like lights. Then large installations, they are just sculptural pieces. You can also design a sculptural piece, not necessarily compulsory that it has to be a functional piece, not necessary. So how it can be tackled, how your design can be converted. So, how are you going to present your drawings, your scale, your material, your machines that you're going to use, how they can be cladded onto your sculpture, the joinery details as well. And then the end product. So if it is a temple, a small temple kind of a thing in a house, this is also an important aspect for you to understand. A temple can also be a product in this competition. You need to understand that. And it can also be futuristic. And you can also use technology in build temples. What if it is a bed or a bed back? So a revolving bed, a lamp, a ceiling, a bathtub. If it is a bathtub, then what? How it can be treated? A bed, a bathtub again, a ceiling again. How fluidic designs can be converted into your interior art pieces, and how spaces can be transformed into futuristic designs is something which you need to look into. So if you see the sofa behind, in front of the bench, and in front of the bed, a sofa with a light incorporated, and then it is getting converted into a ceiling. Just a bed, a TV unit, anything which is related to architecture and interiors is what you need to look into when you're participating into this design competition. A sofa, again, how fluidic it could be, how a design can be evolved, what kind of colors, what kind of textures, how a detail can be evolved, and how it can become a part of a space. If it is a kitchen counter, a kitchen top, how a design can also be converted into this kind of details is something again which you need to look into. It is functional again. The design is there. The futuristic element is there again. A mandir on a different context. A bed again with a different subject by itself. A washroom, if it is a washroom, how a wash basin, how a WC, how a shower can be treated. How a mirror can be designed. How a wash basin out here, you can look in. How a wash basin can be detailed out. We're just trying to give you examples for you to understand and probably get inspired and try to understand how to select a subject, which is again very important. How your wash basins could be a part of a design that we are looking at. So these are different washrooms that I'm trying to show you. This can be a reception table, a small meeting room in a car showroom that we have designed. So meeting rooms could also be like this. So the detail has been designed and derived from the chassis of a car. And 4 people can sit inside this and have a meeting. So we are now designing a car showroom in which we have proposed this. These are a few of the examples which we received last year for Unfold 01 competition. These are the final winners, which I'm trying to show you. Look at their presentation, look at the details, how they have tried to express, the mechanism that they have tried to express, the sections that they have to try to present. So I'm just trying to tell you, this is the second one last year. This is for Unfold 01, the entries which were shown. This was a staircase that somebody has designed. So this is a light again. This is an installation which we have finally installed in a public space. This was also a winner. So I have installed this in one of the public parks in Navi Mumbai. So that's how the construction went on. This is how the project took over. So we proposed this for municipal corporation in Navi Mumbai, and we have installed this now. So that's it. Yeah, Prithvi.
Yes, sir. That was a amazing presentation. I think we should have done it yesterday also. Yeah, I think the students would have got and the participants would have got a better idea as to what we are looking for here in Unfold. And I think it was a very inspiring work, sir.
Sure. Thank you. Any questions that anybody wants to ask?
We are opening the space for some questions about the event, about the competition, as well as any other queries that you have. You can post it in the question answer box.
So regarding the competition, if anybody wants to ask any questions, they want to understand anything much more. So there is a question, what materials have you experimented in? Okay, so the materials could be, for me, we have experimented in, especially in concrete, then wood, marble, metal, right, stone. So there are multiple things. Nowadays, we are working with resins and again with marble powder. So a lot of things that we are trying to work with. So there are different kind of materials is what we are tackling today. So it depends. Even brick, for the matter of fact, you might have seen it in the presentation. So you can think of using any material as a part of your design program and probably understand how the technology can become a part of it, and you can unfold the things and design the things and build it. Okay, there is something called how do you want our end design to be submitted. So we have already given the brief to you. So you need to understand that there is a certain kind of a volume that we are looking out for. So the volume could be 8 feet by 8 feet by 8 feet, but that could again be explored by saying by 2 feet by 2 feet. End of the day, it has to be 128 cubic feet is what we're looking at. So if it is a chair and if you have to increase the size, you have it. So it's your thought process that you need to look into. But the presentation should include every detail so that it becomes very easy for the jurors to understand your concept from the start point to the end point. So the design concept is necessary, the presentation is necessary, and the design details are necessary. So that is something which you need to deliver as a submission. Okay, there's one more question saying, the Baldi from third semester, I want to ask, according to you, what does parametric exactly mean? Okay. See, parametrics is of different nature. Okay, so it all depends upon how you're trying to use the calculation process in a design, to make your designs very easy. Okay, so many times what happens is it is not only about working on softwares, but it is also about how you are deriving your details with respect to the design that you have detailed out. Okay, and also when you're working with materials, parametrics doesn't mean that we are completely working on softwares or completely working with machines. Okay, so it is all about the design and the end limit what you're trying to achieve. That is something that you need to look into. Then, as we have seen, hard materials is being used. Can we go for soft materials like used in sofas? Yes, of course you can. It could be anything. Materials is something, no stopping about materials. Does giving flow to a structure or adding any curvilinear means parametric? No, not at all. Curvilinear doesn't mean that it is parametric. Parametric can be anything. It can be small, simple rectangular patterns, which could be created in different ways by giving different parameters to each and every surface or an object. and a complete bigger picture could be achieved. So it doesn't, you don't restrict yourself by saying that parametric is fluidic forms or parametric is a different kind of patterns which you derive through software, and then the final output is something which you're looking at. Not at all. Parametrics was always there. Indian temples were derived and designed on completely parametric architecture, which we also need to look into. So we have never explored those areas. We never understood those areas. But today, the subject of parametric is being proposed on a much bigger scale, and we're all fascinated with it. And we all want to probably achieve certain kind of details and execute them. Okay. Then, so to you, is the design important or the thought process behind it? Both are same. The thought process and the design are same. Okay. So both are important in nature. So your thought process, end of the day, is going to get converted into design, which will get converted into execution. Yeah. Repetition that is pleasant to eyes, right? No, not at all. Why repetition? Pleasant to eyes could be anything. It could be just one single square also could be pleasant to you, right? Okay, sir, have you tried any designs with biodegradable materials? Not many, because end of the day, we are into execution today. So we are still working on. In India, the research that we are trying to do is at a very slow process. So there are no great or big institutes in India today who are trying to help us out in terms of doing research on materials. As architects, we are trying to explore different probabilities and feasibilities in terms of getting different materials and work on them. Yes, of course, we are trying to work on different kind of materials which can be degradable in future. Okay, so we are still in the process. So it's not an easy thing, but we are still in the process. Probably soon we will be. Okay, can we use cloth of curtains as well? Yes, of course. Recently, we did a small experiment on a fabric where we put a fabric and then put fan around it. We put fans behind it and let the fabric flow, and then we try to spray resin on it to make sure that the fabric retains its shape. So there are different methods to experiment and explore your thought process and convert those thought processes into designs. So there was a question saying that whether the thought process is important or the design is important. So I say both are equally important. My question is, while designing parametrics, for example, you showed in the interiors, but the exteriors is a simple facade. Shall it be called a parametric structure? Yes, of course, because different parameters have been used to cut those slices of brick and create a different kind of a facade. So hence, it is a parametric design. So you have to understand that. What are
So
the
we have one more question saying three more questions. One is saying, while designing parametric, what are the major things we should avoid?
Avoid making errors. Okay. Make a complete research on whatever you're doing and then enter into the design phase and then to the execution phase. If your research is poor, I don't think that your design will be carried forwarded into the execution stage. So your research is very important before even you design anything.
There are two more questions, sir, which I've got separately. As an architect, I'm not sure about whether my design will be structurally stable or not. How do I handle that?
There has to be structural calculations to everything. So if they're lightweight structures, I think your calculations are very easy. With just looking at the object, you can basically understand the weight of the structure. But if you see one of the sculptures which we designed was 120 meters long, which was a huge sculpture, which is 80 tons, which was weighing 80 tons. So then you need to do some structural detailing, structural designing. A structural engineer has to be brought into the picture, and he has to be a part of your design execution. So structural detailing has to be done, which is a must. If you're doing large structures, and especially when you're working for public spaces, and when you are making your structures which are hanging from the top, then of course you have to.
Another question is it necessary for the design submission to be in digital, or can we also submit manual renderings also?
It depends on how best you can present. So manual renderers is not problem at all. So you can, but it depends upon how you're detailing your content and presenting it. So that is something which you need to look into. Yeah.
Then we have two more questions here. As we go for parametric designing, is it possible to go for ergonomics?
You have to, yes. If it is a chair, you have to, right? You can't play with the ergonomics at all. If it is a chair, it is a sofa, you have to think of ergonomics 200%. You just can't delete that. So it's necessary that any product that you're trying to do where a person or where a human is going to use it, then yes, of course.
And are there any limitations to parametric designing? If yes, what and why, and how to counter that? Or what are the common problems architects face while designing?
See, there are no problems at all while designing parametric structures. The only thing I said is if your research is perfect and what is the intent of you to design for a certain kind of a subject, that will matter a lot. So I don't think there are problems. Yes, what are the problems you said that the architects are facing? The major problems that architects are facing today is how to execute them. Okay, that is one thing where major of the architects or major of the contractors are failing in today, because these kind of structures can only be dealt with technology. That is something which you need to understand. Technology means there are machines, there are different kind of tools. See, if somebody wants to build a car, without technology, without machines, you can't build a car, right? So you need to have the technology in place. So today, if you are looking at automobile industry or the mechanical industry or the aeronautical industry, they all have technology within their institution, into their factories. But today in the architectural industry, the architects are not practicing machineries at all. So we need to do some machine learning before we enter into practical execution of parametric architecture, which is necessary. So most important thing is you have to make sure that you learn the idea of machines, through those machines, how you can build your structures. That's something which you need to know first. Yeah.
Then there's another question, sir. Last one. What if I don't know how to detail the design? Will folds guide us? That is the question, sir.
See, folds can guide you once the design is submitted. And if you're selected as a winner, okay, folds will guide you how to build it. So 200% for sure, if you're a winner, the jurors feel that your product or your design that has been submitted is the best design, then 200% for sure, folds will guide you how to build your product and what are the tools that will be used. And moreover, this is a live workshop that we are doing.
The questions are just keeping on coming, sir. So we have another question. Can we submit model for design product?
Yes, absolutely. Absolutely.
And then what all softwares do you recommend to use for effective parametric design?
See, anything. I mean, if it is Rhino, you're using a plugin like Grasshopper. If you're using Max or Maya, so I mean, all 3D software, Blender, Houdini, all the 3D software which are available today and which are easily handleable by you guys, I think you should use them and make sure that you deliver the right product or the right design, I would say.
Then what's the most common material used in this type of designing, especially for curves, except
there
for
is
ACP and all?
There is nothing common. All the materials can be used. If there is machinery with you, every material can be used. Every material which is available within the field of architecture, it can be molded, it can be curved, it can be cut, it can be engraved, and you can derive your design. So don't worry about the materials. You have to be very strong in terms of understanding the language of the materials. So that's when I say you need to know the research. The research is very important. So when you're tackling with design, your research has to be perfectly at place. So any material you can think about, any material which is available today on earth. Okay?
Yes.
Yeah.
I think we can close this session. Definitely, you can put forward your questions in the question answer box, and we will be taking it up as and when the speaker's presentation is over. So I will just keep the questions open as and when it comes. And so we can move forward with the first speaker, sir.
Yeah, done.
So we have our first speaker for the day, Raj Sahani sir, architect Raj Sahani sir. He is a successful businessman, product inventor, marketing whiz, ace photographer, philanthropist, traveler, and a closet artist. He has made quite a name for himself in New York and Mumbai as a prolific sculptor with a knack for creating exemplary human figures. He currently sits on the board of Indo-American Arts Council in New York, was on board of Art Students League of New York, American Fine Arts Society, and Mao Teen Program, which is a sister concern to Miss America and biggest nonprofit scholarship provider for girls worldwide. I welcome you, sir, today for today's event, and the space is all yours for presentation.
Thank you for that introduction.
Welcome, sir.
And I've really enjoyed listening to Krishna speak. Krishna, you are so passionate, so passionate. I just want to tell all the students that be passionate, bring passion, but think of design as sexy, as fun, as not limiting at all. There was a supermodel who said, I don't get out of bed until I get $10,000, you know. For me, I get out of bed because I'm excited that today I'm going to create something, I'm going to build something, I'm going to bring something new for myself and for the world at large. This is Raj Sahani, and I live in New York. I've been a businessman, but now I'm a sculptor, and I have been a designer for a very long time, product design primarily, and I've been awarded a bunch of patents from the USPTO, from the US government. And I started designing internationally for products that were sold on television that could be quantified. As soon as we developed a product, we put it on television, immediately we knew the response. And having done that for a few decades, made me perfect my design, made me realize that design has to be extremely emotional, has to connect with people, has to excite people. And saying that, you know, there's so many things that impact design. And when I gave up my business, I decided I'm going to do it all, you know, put all my life and heart and soul into it. I started photographing, and some of my photographs excited me so much, and I learned so much from my photography that every time I took pictures of, you know, different parts of the world, of the human body or everything, I completely related everything to design. So design is what excites me. Design is what gets me out of bed. And I'm excited to share all of that with you. Having said that, let's go into showing you what I do. So let me get into my presentation. Okay, so this tells you a little bit of who I am, what I do, and it gets me, you know, to share with you what I do. I am excited to work with the design team here. I'm excited to work with the students who are participating, and I cannot wait to see all the designs that you all submit. And let me tell you what I do and how I do it. So this is a product that I developed in the US. Between 60 to 80 million Americans bought this product. This is a very simple thing, and I'm going to explain to you why that design worked. This is a product, it's a simple product that takes calluses off your feet. And most times you can only take calluses off your feet in a bathroom. Now, this is not a desirable product, it's not a sexy product, but yet we got about 80 million Americans to buy this product. Why it worked was design. And when I say design, you can sit watching your television, you can sit with your children while they're doing their homework. You can sit anywhere you want and take the calluses off your feet. The design is such that the product fits in your hand and it collects all the calluses in the container, which you can go and dump out later. So you can see how that works. And when I say design, the design incorporates everything, including how the packaging is done, how it is explained, because on the packaging, we have to explain how it fits in your hand. And design also mattered where we photograph the product and we present it to the consumer. So the design is extremely important. one of the things that, after we launched this product, we realized there were a lot of people who could not reach their feet. So we came up with another design, which put a handle to the product. And that way we covered absolutely 100% of the population. There isn't an American who probably did not buy this product. This was my past life. Since then, I become a sculptor, and I have been sculpting products, sculpting art. So that is some of the things that I do. So form excites me, shapes excite me. So just look at the things that I've done. See, Arzan was talking the other day about impossible. There's nothing impossible. Over here, when I made these sculptures, I wanted to make it stand on its toe and take the magic out. How was this done and how could she balance? If a human can balance, so can a sculpture. So keeping that in mind, all of these were created. Video. How's that on the video?
Yeah.
This is how we do it. It's Friday night. I feel alright. The party's here on the west side. So I reach for my 40 and I turn it up. I'm the dictator, I'm gonna take the keys to my truck. Hit the shop cause I'm faded. The honeys in the streets say money, yo, we made it. It feels so good in my hood tonight. The summertime suits and the guys that can high. All the gangbangers forgot about the drive-by. Get your groove on before you go get paid. So tip up your cup and throw your hands up and let me hear the party say. I'm tired of and it's all because something cooked up the night normally does. So all my neighbors, you got much flavor. Let's flip the track in the old.
All right, guys. So you saw my process of how I do it. There's a lot of research that goes into design. And in this case, I'm only going to talk about design because a sculpture is a design. It comes out of my head. It's really exciting, but I have to do research when I want to create something like this. I have to get my models involved. I have to see whether the human body can do these moves, and then I can put it, and then people will connect to it. And it has to be real. It has to be very honest. You cannot just come up with something that doesn't touch people, that people don't understand, and expect them to appreciate it. So the design has to be emotional, it has to be very honest, and it has to connect. I'm going to show you another one that I did. So as you can see, I'm having a lot of fun while I'm doing what I'm doing. Designing has to be fun, it has to be exciting, it has to take over your life. And then you can take some liberties. I had two guys posing for me, modeling for me, but then while I was making the product, I decided that I'm going to turn one of them into a female, and that worked. And it made it more exciting, it made it better. So you can always evolve, you can always add, you can subtract. So, and here's another one. Sometimes I just start with a photograph, and then this is the final product.
Some say follow you. You'll never stay. Some say.
All right, so follow your heart. That is very, very important. It will guide you. It will take you to the right place. If you can think it, if you can dream it, if you can put it down on paper, and you can figure out how to make it viable, how to make it new, how to make it exciting, then everybody will connect to it. Design is something that should be easy. A child should understand, a grown-up should understand. Design has to be innovative, it has to be useful, and it has to, everybody has to understand it immediately. I mean, in this case, it's very universal. These two girls, this man and woman, although they're dancing and they're balancing and everything, it is universally they're making a heart, which is kitschy, but sometimes it's a lot of fun. You have to put some fun element into it. You have to figure out whether it's going to last a long time. And then you have to look at the last detail. You have to put as much detail as possible. You have to think about everything and take away anything that distracts. Now I'm coming back to how, you saw me do all kind of figurative work. I had a client who wanted my sculptures, but had no space on their tabletop. Sculptures, you need a lot of space for sculptures. And to work around that, and they own very important works of art. And I came up with the sculpture that comes out of the wall so that it brings another dimension. So another design element to that room. And makes everything three-dimensional. Instead of having flat art all over your room, this brings out another dimension, another excitement in the room. So when people walk in, they get excited. When they have people over, there's so much to talk about, so much to discuss, because you have another element that is staring at you. So this is how design works. This is how simple design works. It doesn't have to be complicated. Most great design is very simple to execute, and will last forever. That's another how I created the wall sculptures, with the problem that people have of not being able to put sculptures on their, desks and places. So these are sculptures, but I look at them as design. They have to be designed for a space. They have to be designed for a reason. They have to be useful. There's no point in creating something that nobody understands. And this idea can be applied to every concept, whether you're designing a building, whether you're designing a toy. It has to, change the quality of life. It has to raise your spirits. It has to enrich the environment the design is going into. It has to be prestigious, because you have to, people have to walk in and people have to look at your design, whether it's a building, whether it's a room, whether it's a product, whether it's art, and it has to be very prestigious. People have to be proud to be part of it. Nobody owns anything. People, the association has to be very prestigious, and it has to be very useful. And then you have to take away anything that distracts from design. You have to keep paring it down and, going for it. This is another thing where I'm talking about, product and design being very emotional. I had a client who wanted a Jesus in their room, but the most important part of the Jesus was the emotion, and to get the emotion right, and the face right, and the arms right, and the small details matter. Like when you buy property, you say location, location, location. In design, it's detail, detail, detail. So that is very, very important. Every small detail is very important. Now, this is another design I'm showing you. We had the Indo-American New York Film Festival, which is held in New York every year, and they wanted to design an award. And they came up to me, and we wanted to, this is an Indo-American union. So we came up with this design, which had a very, everybody knows what the Statue of Liberty flame is like. So we took that element, but we put a lotus flower at the base so that it marries the two cultures. And it's very important. It's very relatable. It's everybody can understand what it is. And then, they were given away as awards. Now people were very happy to get an award like this and take it back and display it. So like I said, it has to be extremely prestigious, and not because it's gold. It has to be prestigious because the design works. In this case, marrying the two cultures, marrying the two elements made all the difference. Now, coming back to design. Now, there are many times you are asked to make a design, and I'm known for my works that my works are all figurative. And Hyatt Hotel in Dharamshala, which is close to the Dalai Lama, wanted me to come and make a large sculpture outside the hotel. And I went over there and I looked at the location, and they wanted a large sculpture. It could be figurative, it could be the Dalai Lama, it could be one of those things. But when I went over there, when I saw the piece and I saw how beautiful the space was, there was nothing that I could think of that would go over there and make it better, or make that space more precious, or make that space more desirable. So I decided that instead of creating something, I'm going to let what is there already, and I'm going to enhance it. So I came up with this sculpture, which was faceted, which all it did was reflect back the energy that existed over there. So the design can be very simple. So I didn't put a picture of a sculpture of Dalai Lama, or I didn't put a dancing girl over there, but I took what was there, the beautiful clouds, the beautiful trees, the beautiful mountains. And as you drive around this, you see how it works. And so all I did was give back what existed. A good design is extremely simple. It has to work in the space it is, and it has to, and the only limitation was transportation. And that's why we did not make it bigger, because there's no truck that can go up to the mountain where we had to put the sculpture. So we had to limit the sculpture to 18 feet. But what I'm saying is extremely simple, extremely, it's like we took what was there and we put it back, we put the energy back. So the design has to be very simple, it has to be effective, it has to be intended for where it is used. Now there's another design that I had to design for Baku in Azerbaijan. So I want to tell you what was going on over there before I go into the design. So in Baku, they believe that the pyramid is the most precious architecture that is there. And they also believe that there are 4 flames that protect the entire city. So their belief is that there are flames protecting the city, and it's centered around a pyramid. And I had to design a sculpture that they wanted to put in the Baku Museum, which did not happen because of COVID, but it's in the process, and now it will happen soon. So this is what I came up with. This is a pyramid in the center and the flames going around. Now it is, when you look at it, it immediately attracts you in, and you want to know what it is. But looking at it, it was not as simple. So when you design, you have to take away everything that is not useful and simplify it. So we went from there and we simplified it. But then we realized that in the simplification, we also took away, we got the 4 flames around it, but we also took away the pyramid. So we put the pyramid back and we call it pyramid, which is fire and the pyramid. And that's the sculpture that was approved, that is probably going to go to the Baku Museum. And hopefully it'll become iconic, and people love it. So simplicity, why it is made, that's a big question. Always when you design, you have to be like, why is this being done? How it is going to impact the culture, how it's going to impact the location, how it is going to impact so many things, So, and all these things impact design. If the economy is not doing well, the designs are different. The luxury is different, and what you can do is very different. So all that has to be taken into account. Now, when you're designing, you also have to talk, Krishna was talking about what materials can be used. Now, typically, when you think of sculpture, you think of, metal, sculptures are made out of bronze, they're made out of wood, they're made out of all these things. Now, how to think outside the box, how not to limit yourself. And I push myself every day, to see how it is innovative, how it is different, how it is something that has not been done. How can I make possible what has never been done? So this is something that I tried in my, this is something I'm working on, and I gave it a good shot, and this is what I did. So watch this and see if you like it. I used a material which is never used in sculpture. Nobody thinks of that as sculpture, but this is what I did. I do figurative sculptures, and that's what I wanted to stick to. Now, we don't think of paper, we don't think of cardboard as sculptures, and we don't think we can make traditional sculpture out of this. You can make something funky, you can make something else, but I'm trying to stick to my style and work with the material that has not been used. But this is new. This is pushing myself, pushing, what can be done, what cannot be done. This is completely made out of paper, in and out, without any other material used. So this is just to show you how any material can be used. If you can think it, these days, there are glues available, there are things available, there are machines available. You can push the limit. And the newer materials you use, once you use it, your whole design thing gets expanded, and now you can go ahead and create so much more. The other thing I did was, you have sculptures outside temples that are all broken up, and they're all made of stone, and I wanted to finish them, but I decided to use a different material, and I decided to marry metal with stone. And as you can see, these the temple sculpture is broken, and I'm trying to finish it with metal. So this is how I finished it. Instead of using stone to finish stone, I decided I'm going to use a different material to finish it, bringing another dimension to the piece, making it a little more exciting. So even though it is traditional, I used different methods to finish a product that is extremely traditional, which everybody identifies with. There is familiarity, everybody who walks in can understand what it is. And this is what the finished product will look like. So you have stone, you have metal, and sometimes the simplest things are fun. If you look at the most expensive sculpture in the world today is a balloon dog that is made by Jeff Koons, and that is made out of metal, but it is replicating a rubber balloon that everybody identifies with. Now, why did that become so popular? Because everybody who looks at it brings a smile. It's familiar. When you were a kid, you enjoyed a balloon that made in the form of a dog, and now you get to keep that balloon forever in good, in great design and executed brilliantly. Of course, detail. You have to be, it has to have the aesthetic. It has to. God is in the details, and Jeff Koons got it, and he put the detail. He put everything, and he used a different material to make a balloon. Brilliant. So you go out, you guys, come up with different materials, come up with different techniques, come up with different designs. There's no limitation to what you can do. So surprise yourself, surprise us. We are very excited to see what designs you guys come up with. And, I'd love to meet all of you guys. That was my presentation. So if anybody has any questions that I can answer, I'd be more than happy to.
It was a wonderful presentation, sir. Thank you for bringing it to light. We have already some questions here, which we can take. So the first question is, what all materials you have used for making such sculptures, and also what do you expect from the participants?
See, I have not limited myself to material. I don't think in terms of material. I think in terms of forms. I think in terms of shapes. I think in terms of design, and I think in terms of what I want. So I have used definitely clay is, the basis of my sculptures, but then I have used, they all become bronzes. I've used wood. I am trying to use glass. I'm trying to use, my association with Krishna has expanded what all I can use. And I come here sometimes and I look at what can be, I've tried to use resin, paper you saw. Now, these are all things that are typically not used. So I'm not limiting myself to the material. I'm not letting that happen. I'm trying to first design. I'm trying to see what I can do, and I'm pushing myself. So every material is, gets a free pass, and I can use all the materials that are out there.
Wonderful, sir. So we have another one. Can you explain your process of fabrication of your designs? How do you sculpt metal? You start with clay or paper, and then how do you do it in metal?
Typically, sculptures are made out of clay, wood, materials that are malleable. Metal, you never make a sculpture out of metal unless you're as brilliant as Arzan Kambata is, who uses scrap metal and comes up with sculpture. I'm a big fan of Arzan's work. But typically, all the metal sculptures that you see are initially made out of a different material and then cast in metal. So I start with clay and it turns into metal. Of course, if I use different materials, then they stay as they are. If I make something out of paper, it stays in paper. If I make something out of glass or wood, then that's what it is.
Okay, sir. So, what all materials you have come across or experimented with? Also, are you thinking of using it in future? What all are you thinking of using it in future?
I'm excited every day. Like I said, I get up in the morning and I cannot wait to see what else I can create. Luckily, we are in a day and age where I have access to every material that anybody uses around the world. So when I'm driving to work, I'm on my thing, looking at what somebody else has done, and not necessarily in sculpture. If somebody's used brick in buildings, I might be like, what can I use brick in my thing? Or there are people who are using pencils and putting resin around it and then, making different things. So it's limitless. These days, any material is fair game. You can marry materials, you can mix materials, and there's no limit to what you can do. Because there's so much machinery, there's so much technology, and what they cannot do is to come up with the design. So that's where we come in. Material and, it just makes it better.
So there's one more, sir. How did you design and fabricate the mirror finished sculpture?
Well, mirror finished sculpture is a lot of work. It's marine grade steel. So when you weld all the pieces together, first you design it and you facet everything. It's a lot of work. It just goes from every grade of polishing to the finest grade of polishing. And it is labor intensive. It's a lot of work. There's more time spent polishing steel or anything than it is creating it. So, there are machines available to polish that make life easier, but that can be used only when the surfaces are plain. But when you have, like in my stone and metal sculptures, you literally have to go with your fingers into every detail and every crevice. So it's a lot of work, but it's zen. It's a lot of fun.
Yeah, I get it, sir. So there's what are the challenges you have come across while dealing with different types of materials?
But there's a challenge in everything. That's what makes it exciting. And at the end of the day, if there were no challenges, there wouldn't be fun. So every material has its own challenges and limitations. Every material. So you have to understand that. You have to understand the material. You have to understand why you're designing. Then you have to understand why you're using the materials that you're using. And then the design works. every material cannot be used for everything. So every material has limitations. Every material can be applied to different applications. So you have to understand the material. You have to do a lot of research on why you're making it, where it is going to be, what it is going to be used for, and what materials can be used. And then you push yourself. You push the limits of the material. You push the limits of technology, and you come up with something new. And when you come up with something new, it doesn't have to be new just because it's new, but it has to be something that wows everybody. You know, whether a child walks in, it immediately emotionally connects with everybody. And material is not important, but understanding material and why you're using it and how to apply that material to the design you come up with is the important part.
There's a question that came before your presentation, sir, but I thought you could also answer that. Can you suggest some buildings or structures for case study for a better understanding with regarding to this competition?
Well, just go out. Everything is design. Everything is, you don't have to look at buildings to understand design. You have to look at anything. Look at a scissor and see how effective it is in what it's supposed to do. It's easy to understand. It's easy to use. So everything that you look at every day in your life should inspire you. You have to understand why it was done. You have to understand why a space is constructed in a way it works. You have to understand how the flow works. You have to understand how the design works. And finally, then how everything came together. What the person who designed was thinking, and how that design was inspired, and how it was executed, and how it is functional, and how it is immortal, how 100 years later it is still working. So design is everywhere. Get inspiration from everywhere. Go into your mother's kitchen, go into great buildings, go online, go look at all the great people who've done it. Just it's inspiration everywhere.
There's one more question where they have asked, you mentioned using resin. How has it helped you in your process?
Well, using resin is new. It has not helped me in my process. It has given me another material to try out. It has allowed me to look at another texture. It has allowed me to push my sculptures. So a new material, it doesn't help me. It just gives me another dimension. It allows me to think differently. Now I can think of how I can incorporate it, and I can push my pieces of art, and how I can bring more design into my sculptures. So every material allows me to expand my possibilities.
Okay, great, sir. So we'll take one last question before we go to Krishna, sir. So there's this question that has come. Have you done any parametric or fluid designs with broken sculptures?
I'm sure I have. I'm sure I have, because with broken sculptures, there's no such thing as broken sculptures. Everything is a piece of art, and what you think of it and how you want to execute it and design it and make it. So there's fluidity to everything. There is. So yes.
Yes.
Yeah, that was an excellent presentation, Raj. I just want you to tell people, because I know your background. So I just want you to tell people, at what age did you think that, you wanted to start this new kind of a passion that you had?
Listen, I wanted, I'm much older than all of you who are in this. When I was a kid, my parents would not allow me to, there's a fly here who loves me. So, well, anyway, so I retired. I stopped doing business at the age of 50, and I decided now I'm going to follow my passion. Passion was design, passion was art, passion was all of that. And I've only been sculpting for the last 5 years, and have been very prolific. I get up in the morning, I work 15, 16 hours a day in my studio, and I'm having the time of my life. So there's no age to start. There's no limitations. And I'm glad, I've been allowed to, I'm blessed. I've been allowed to do what I love to do. And I'm glad to, learn from everybody, learn from Krishna, learn from Arzar, learn from the internet, learn from all these people and apply it and enjoy it. Because when I create something, I think I enjoy it as much as somebody else will enjoy it. So, yeah, I'm not in the prime. I'm 63 years old, and I am loving it, and I'm living it.
Awesome. That's something which we all need to get inspired from. I mean, Raj is such a wonderful person, and the kind of designs that he is trying to execute today in terms of sculptures and the way he is trying to connect. Very important is getting connect to the space first, understanding the beauty of the space, and then designing for the space. That's what everybody should be doing. Then that's something which you need to look into. Materials, I shouldn't say that there should be a barrier for you. For anyone, for all of us, it shouldn't be something which should stop us from designing. So materials can come later on, and at least your design and your passion should be very important. So thanks a lot, Raj. If any more questions, Prithvi, you think that you want to push across?
Yes, there's one question, which I think even Krishna sir can answer. Can we use materials which are readily available but not economically feasible?
Yes, absolutely. Again, I want to say again, you should not restrict yourself to the materials which are available today. Just explore your designs and also explore different materials. We will tackle it if it is particular to the competition, we will tackle the materials to whatever extent possible, but don't stop. That's what I would like to say. Yeah, Raj.
You might think the material is expensive and not feasible, but a different market. The world has become smaller. It's become a village. There might be a different market or a different way to execute the same thing and make it feasible. So if you can think it, if you can dream it, do it. And learn from everybody. Every day. When I was doing my business, I should take kids from Princeton University every year. They would follow me to my factory. I used to take them with me to China. I took them with me to Germany, and I would learn from them. I was supposed to teach them, but every day I would learn from them, and I'm applying all of that today. So just learn from everything that's out there, every material. Just push yourself. Try something new. Surprise yourself. Surprise us. Surprise the world. Make it a better place.
That's lovely.
Wonderful,
that was
sir. Wonderful.
Wonderful. Absolutely wonderful, Raj. Thanks a lot for joining in. So I would love if you are present and to listen to the next presenter. So, be there. He's already there online. So, Prithvi, I think we can invite Joshua and, tell him to start his presentation.
Yes, sir. Yes, sir. Thank you, sir. Thank you, Raj, sir. It was wonderful to see your presentation. It's very inspiring. Thank you so much. So we'll move on with our evening, and I would like to welcome our second presenter, Architect Joshua Vermillion. Architect Joshua Vermillion is a tenured associate professor in the School of Architecture at UNLV, forging a multi-year career in exploration, development, and execution of digital craft. His efforts in research, pedagogy, and practice belong to three primary categories: digital information as a medium, as a material, and as a method. So in all these three, in three places, he's been working in terms of computational parametric algorithmic design, digital fabrication tools and techniques, situated technologies, responsive systems, and robotics. So Joshua has also taught in many other design studios, seminars, and lectures across the Ball State University's Department of Architecture. While he was there, he also co-founded iMade, an applied research plus immersive learning institute focused on bringing together students, faculties, and design professionals with regional industry partners to work on mutually beneficial projects utilizing design, computation, and fabrication. He has also spoken worldwide in many notable forums and has published and presented peer-reviewed research in conferences and famous journals. So I welcome you, sir, and open up the space for your presentation.
Thank you so much for the lovely introduction. And it was really great to sort of see all the presentations thus far. Let me just share my screen. All right. Hopefully my slides are showing up. So again, thank you for the invitation. So I think I better understand why I'm here, and I have hopefully an interesting presentation to show you and some work to talk about. And some. Can you see my presentation?
Yes, I think when you move the cursor, it came. The next, can you move to the next slide?
Yeah, let me see.
The sharing stopped.
Uh-oh. That's weird. Can you see now? Hello?
You're there?
Is anybody there?
Yeah, I'm here. Joshua, I can
Okay,
hear you.
sorry.
I can hear you.
All right.
Yes,
Trying
we
to
are
share
here.
this. Okay.
You need to share your screen. Yeah.
All right. And are my slides showing up now?
Yes, it is.
Okay.
Can you move to the next slide?
Can you see it?
There is a slight problem with the presentation, I think.
Yeah. Is there a video? Because it's shown and then it gets disconnected.
No.
He has to press play.
So I'm pressing play, and it's just a slideshow in Keynote. Hmm. That's weird. It won't let me.
Is there a video in that, sir?
Yeah, well, can I just share my desktop? Because it's every time I hit play in my presentation, it
No,
doesn't
I
seem
think
to work.
you'll have to play it and then share it, because I think when you
Okay.
play it, it goes to the
Okay.
screen. Yeah.
Sorry about this. Now I don't have an interface for Zoom. Let's see. Trying to move my cursor around. Yeah, I'm not sure why it won't. All right. I'm sharing Keynote. And can you guys see my slides now?
No, no, sir.
So instead of playing, you can go one slide at a time, no? Yeah, we can do this.
Sure. Let's do that just so it
Yeah, we can do
things
this.
up.
It goes one slide down.
Okay.
That's fine.
All right. My apologies for that. So at any rate, I'll just go through some projects that I've worked on in the past, also with students and other collaborators, and talk about some of the things that I've learned along the way. This first one was introducing students to robotics, but in a very quick, short way, on just a quick 2-day workshop, very intensive. They didn't have any experience before with robotics. And so, it didn't really stop us from accomplishing a lot in a very short amount of time. This are pieces from a Lego NXT robotics kit. And so what we did is we just borrowed something off the shelf in order to begin to prototype. And that, I think, is one of the first things I would say: make, prototype, prototype, prototype. You can't talk to us or tell us what you want to do. Show us what you want to do. Try it out. Fail it a couple of times, right? Don't be afraid of failure. Embrace it. Very quickly, then customizing that kit of parts that came in a box with our own parts. This just involved a lot of laser cutting and testing and snapping things together over and over and over again over the course of about 24 hours. The idea then was to think about modularity, make this kit of parts, extend it, then make it move using a set of gears and drive belts and sensors and some stepper motors. And again, just really quick, fast-paced prototyping, a lot of testing, a lot of figuring out how not to do it before we finally found some ways to do it. And that's, I think, the spirit here. I wouldn't try to sort of solve everything in my head first. Work with materials. Materials will tell you exactly what they want or don't want to do. And as soon as you can learn that, then I think you're on the right track. We had to develop these sort of non-architectural details, like how to attach this to an existing glass window and using suction cups and things like that. And then how to make it architectural. It's kind of a fascinating set of details as we turn planar components into a three-dimensional construct that has structure and can move around. Let's see if I can get this video to play. Right, so here we have somebody sort of setting off the IR sensor, and then that activates this dance routine almost of these panels moving around. And honestly, probably, maybe another couple of days away from, expanding the scale of this, and then thinking about how it could be used in a performative way when it comes to daylight and program and etc. So. This is an installation that we hung in another building with the artist and architect Philip Beasley from Toronto. This was a big group effort. Philip does these magnificent hanging installations that you can sort of walk through and be immersed inside of. And so one of the things that we really learned from this was this powerful idea of simple parts and modularity, but then extreme repetition, right? Repeating things over and over and over again in order to create a field. What I mean by that is we have a sort of grid, and we have a lot of components, but then some of the components are repeated, but slightly different, right? So a difference in repetition. You can see here that these are basically custom laser cut acrylic components that form a sort of corrugated diagrid substrate that's hung, and then we extended bamboo and these mylar leaves from it. The way this works as a system, an active system, you can see here in this diagram, what we did is we hung these with a sort of A-frame that acts as a hinged lever with an custom air muscle right here. So we would release solenoid valves to make that air muscle contract. The scissoring effect then would create sort of these pulsating, shaking responses within the system. So as folks would walk through it, they would set off IR sensors, and then certain air muscles would contract in order to create these sort of empathetic responses to human occupation. Here we were putting it together in different, sort of taking the modules and putting them together into these sort of larger assemblies, bringing each of these assemblies and basically hanging them up to create the larger system. You can see we were hanging, in this case, along a waffle slab. So a two-way concrete system gave us a lot of flexibility in how we were able to, for points for hanging and things like that. Just sort of watching that step by step as we move things in and out. And then populate these. Again, I have another video where we were reinstalling or redeploying this system. Because it's modular, we could take it apart in smaller pieces and then move it around or deploy it in other places, which I found really helpful. So I just sort of show you a little bit about what that looked like in action, as well as how it would actually move in situ as folks would walk through it and around it and underneath it. Those are infrared sensors, right? So all of these were just off-the-shelf parts. We were laser cutting sheets of acrylic. We went on McMaster-Carr and other sort of websites, Amazon, just finding, silicone tubing, those sorts of things, clamps. All these things were things that we could either find off the shelf or things that we could find as raw materials and then quickly bend, shape, or cut into place. And there's that pulsating sort of event as these things would move around as people would walk through them and sometimes startle people. They were always wondering what this cloud of stuff above them was, and then suddenly it would move and shake on them as they walk underneath it, which I found fascinating. Another example, this was a design for a lighting competition. We decided to make a false ceiling or soffit over a fitting room for a boutique clothing store, where the shape and lighting of the ceiling over each changing stall would change depending on whether it's occupied or not. And here was the sort of idea as we saw it and diagrammed it. We actually got an honorable mention in the design competition, and the comment that the judges had was, "It's an interesting idea. It's too bad it can't be made." And so we said, "We accept this challenge. We will now make it." And we did. So we began prototyping. You can see that we had to not only think about how this thing could physically, mechanically move, but then how to drive it with microcontrollers. This is an Arduino chip. We have some stepper motors, a lot of prototyping involved. Prototyping not only the physical installation, not only the actuation, but also prototyping the code writing, right? The scripting of it to get it all just right. I'm just showing you what that looks like, the messy sort of mechanics underneath as we ran electricity. And again, these are just, off the shelf. This is acrylic that plugs into other pieces of acrylic to change axis. And then these clear plastic tubes, that's just silicone tubing that we cut, right? They can get in rolls and we just cut it and fed it through for making these sort of hinge connections where we needed them. They fit perfectly with these airplane hinges that we found, these model airplane hinges. So we're always sort of looking for ways to do these things. And then we were even able to take these tubes and make our own little custom fixture for our laser cutter. So we could put something that's not flat into our laser cutter and begin to cut and inscribe information into these round tubes. So again, I would say, you could throw any kind of tool at these things, right? But I think the clear thing is to get your hands dirty quick, right? There's a lot of exploration with this and just sort of trying to understand what we could and couldn't do, how we start to make details. Once we started to identify details that we could reasonably make, and we began to understand the constraints of both weight, the sort of brittleness of material and the resiliency of the materials, and then how everything would fit together so that we could easily assemble it, but it would stay together. Then that became the sort of generative rules that we could actually begin to create the larger system. So sometimes it's really tempting to create a shape, and then you fall in love with that shape, and then you try to figure out how to make it, right? Another way to think about this is a more bottom-up way, where you begin to work with materials, you identify some techniques or a detail, and then that detail can become a generative idea, motif, to create something larger, right? So I would highly encourage you to think in terms of working with materials first. It's always easier to work with the material than against the material, right? Here you can see we're just prototyping this a lot, plugging things in and out. And then this was a video from our first test, sort of plugging these things in and then getting them to move and adjusting the torque and adjusting the tension on these lines and right. So we did finally get this thing to move back and forth. And in fact, it got better and better as we went. You can see that was our first try. Then sort of opening up just 1 or 2 cells at a time, So again, there's lots of just trial and errors with that video. I won't make us watch the whole thing. But to suffice to say, then we were able to pack everything up. But one of the other constraints that we looked at was how we would ship this to Florence, Italy to install it in a show there. And so even the packaging, how it was going to be shipped, getting it through international customs became a design constraint that we had to think about as we were designing the entire system. So it's not something that we got to the end and said, oh, no, like, how do we get it there? Like, that was something that we had to think about right away, actually. And it became, I think, one of the main drivers for the sort of scope and scale of this project, right? So you have to think, if you can always have to think several steps ahead, right? So not only do you have to think about what do you make it out of and how do you put it together, but you have to think about how do you get it through a doorway? How do you get it on a truck or get down the streets or put it in a box and ship it off, right? So, and then what are the instructions if somebody else has to build it for you, right? Is it a big jigsaw puzzle full of pieces? If so, then are they labeled? Are there instructions for how to put it together, like Lego or IKEA, or those sorts of assembly instructions that we always see, and that are made for anybody to be able to pick up and understand. Here are some more photographs of this installation installed in Florence, just to give you a sense of what that looked like. It was really quite lovely. I was really happy. And then, lots of projects where, we're not even completely finished yet. We're looking at different ways to transfer rotation into in one direction mechanically into opening and swiveling sort of mechanics to sort of take gearing. It's always trying to minimize the amount of power you actually have to put into these things if you want to get them to move, minimizing the friction, minimizing the weight, and then trying to be as clever as possible with how do you transfer let's say one sort of direction of energy into another, right? Without losing too much energy. So this is an example of that. Here's how we mocked it up digitally. These are some photographs of the physical prototype. Here we were in Grasshopper putting this sort of conformal grid, sort of a non-rectangular grid of these pieces, sort of thinking about each component being related, but not necessarily exactly the same, not identical. And then here we are routing out polystyrene for the pedals with our CNC router. And here's some example prototypes as we work through this. I mentioned weight, and here's an example of that. You always have to think about the weight, right? Materials have mass, they have density, and they weigh, right? So this is an example where we were working with stone. And so we had to try to measure each of these pieces of stone. These are looking at stone offcuts from the production process. We're trying to figure out a way to monetize the sort of waste of the industry. There's a lot of energy already used in extracting these big blocks of stone from the ground. But a lot of them don't actually get used because of the quality of them. And so we were looking at ways to sort of think about how digital technologies could help us reuse some of these blocks that have already been extracted from the ground and are just sitting there. But the weight of stone is of course quite large. So we couldn't bring the stone to the measuring equipment. We had to bring the measuring equipment to the stone, right? And that's a lesson to be learned, right? These things have weight, and particularly if you're starting to put things together, right? We saw wonderful examples from the first two presentations, sculptures and really interesting geometries. But depending on the materials, right? You have to account for weight. You have to think about the engineering side of these things, how it bears on the ground, make sure it doesn't tip over, but also just simply moving it, or how do you make it, how do you construct it, what kinds of machines and tools you can use, right? Its hardness as well as the weight. There's only certain tools you can use for, let's say, stones or for steels or metals. And they're different than, let's say, woods or paper or plastics, right? So at any rate, this was one of our students using a Faro laser scanner, scanning arm, and tapping on to mark off planar surfaces, edges, as well as vertices. So we could then capture the shapes of all of these pieces of stones in a digital database that could then be queried in our parametric model in order to create non-standard, let's say, building facades out of dimension stone, utilizing some of this waste stone. So, taking this idea a little further, we actually used this with a different material, wood. There was a barn that was being torn down, and the old wood in this barn was actually quite lovely. So we were able to have that donated to us. And then we took each of these pieces of wood and cataloged each one, measured them, washed them, and then we created a digital idea. This is a rendering of some sort of faceted, polygonalized park structure that children could climb on, made out of this wood, plus a few custom aluminum panels. More about that in a moment. But this idea that we made this sort of interesting landform within a sort of public park in our own town. So for the aluminum panels and all of the aluminum connections that were custom, we went to A. Zahner Metals, which is a really good company here in the United States. They work with a lot of different architects, and they specialize in doing things that other companies say they can't do, right? Like, so they relish the challenge of trying to figure out interesting geometries and how to pull them off with metals. So here we are with one of their vice presidents, and actually that's Bill Zahner right there, one of the CEO, with our students discussing, working through this. This is Rhino, and we're just walking through the model and looking at the information, trying to sort of make sense of it, and coming up with a game plan for how we could pull this off and how we could systematize this. And I think that's always the case, right? Sometimes you start to make some decision making in piecemeal, but then the question is, how do you systematize things again, right? I think that's really important. It helps you a lot if you can think in terms of a system, parts to whole, and modularization. What I mean by modularization, it doesn't mean that everything has to be strictly identical, but to think about this as a sort of system where we have similar parts, I think can be very helpful for you and very helpful for people to make it, build it, and very helpful for people to understand it. Here we have some of those pieces of barnwood now being machined out with our CNC router. We actually had a number of custom slots. You can see we have labels here. Each piece was completely unique and had a completely unique location within a larger assembly. We were actually misusing a dovetail joint, meaning that we were creating these slots with a chamfered edge, a sloped edge, so that when we slide these things together, they actually hold together and don't pull out. This is what that would look like right there after being machined on the router. And we even to hold these things down to the router bed, we knew exactly where each screw location would be, and in order to sort of fix these things in place. And here they are being slid together in order to create, along with these custom aluminum clips that Zahner made for us. Here we sliding them all together. And here's what that looked like when it was actually put together. So I always show the sort of digital model. There's the digital model, and there was the physical reality. And it actually worked pretty well. So this is what the underside looks like. There's all those custom aluminum clips, sort of holding everything together, and then tying them back down to these posts that bring everything and bear them to the ground. Right, and within a few moments of it opening, there were, of course, children on top of it, climbing and playing in the park. So fascinating. And that's not to say that you can't just think about something that's very light, right? Here is an example where we were looking at wood and doing something what I would think is counterintuitive with wood. We were looking at wood veneer, and which is shaved down into these very thin strips. And then laser cutting them into components to make these sort of lampshades, and taking something that we think of like wood, we think of the strength of wood. We think of wood as a fibrous, opaque material, and then revealing it as a sort of thinly shaved, translucent material that can bend and sort of flex and be put together, again, like almost like a piece of paper assembly, and sort of doing something showcasing this material in a different way. Maybe a way that maybe the general public, when they were looking at these, didn't necessarily think of when they think about wood. I'm just going to skip ahead here and just take maybe a few more minutes, and then I'll stop presenting. I'll just show you again this idea. These are all just quick models that my students do, right? Maybe it's paper, maybe it's wood dowels, maybe it's string, maybe it's a combination, right? Prototype, prototype, prototype. Make it. Don't tell us about it. Make it, right? You can't just draw it. You can draw what you make, but then make what you draw, right? That would be my biggest piece of feedback here. Reflexively make these things, and it could be very simple materials to start with, right? Again, you can make interesting things out of very simple materials that you have access to. Maybe it's paper that's folded. These are actually blocks of glycerin soap that have been sculpted, so it could be subtractive and not necessarily formative. Or here's another example of the same types of models, but then laid up in cardboard, so they're additive. And then this is nothing but just wall compound or spackle, this white substance that could then be applied or piped, or like icing, or raked on like mortar, and you could begin to sort of experiment, right? In this case, using cardboard, a lot of experimentation with the corrugation of cardboard, right? So thinking about those materials, think about what they're good at. What is the expression of the material, right? You can think of it as, I just want to make this shape, and the material is kind of irrelevant. But what's really beautiful is when you can have a conversation with the material and begin to understand what the material is capable of doing, right? And then begin to understand the characteristics of materials, and then that begins to sort of help you design, right? So I think that's really important. But sculpted foam, or making something three-dimensional out of planar material. This was acrylic that was then laser cut and then slotted and put together to make nice three-dimensional constructs. So with that, I think I'm just going to go ahead and stop sharing.
Joshua, I think you can go ahead with the presentation. We still have some time. Don't worry.
Still have some time? Okay.
Yes, we can go ahead with the presentation. Yes.
Okay, great.
We have another 25 minutes left. No worries.
Oh, okay. We have quite a bit of time. All right. So I will just show you a few other things, right? Which is, again, don't be afraid of going digital here and sort of thinking about taking that digital information. But the question is then, how do you get back to the material, right? There's got to be a feedback loop between that sort of digital model and then the sort of your prototyping, your physical prototyping. This is a good example of this, right? I have students make these sort of grid shells, and so the shape is automatically going to have some double curvature. You can see sometimes the double curvature runs as a saddle. Sometimes it runs as a sort of the double curvature runs in the same direction. But the idea is that geometry can actually work with performance, and then each unit can be populated and actually work with performance when it comes to sunlight. And then they have to make it over and over again. They have to prototype it several times in order to sort of dial in the tolerances, begin to understand how that works. And so here are some of those examples, photographs of their actual prototyping. In this case, just using simple materials like chipboard that they have easy access to, and so they don't feel like things are too precious to just continue to laser cut and put things together and glue things. The key thing is to not be afraid to make mistakes. Don't make mistakes, but if you're going to make a mistake, make it at the very beginning. Have plan B and just continue to refine, right? So here's the key thing, right? Prototyping is not something you do at the very end. Prototyping is something you do throughout the entire process to test, to evaluate, in order to understand and anticipate the problems and challenges that are coming up. So you can start to see that they're actually quite prolific in generating a number of prototypes here to sort of work with, right? And what I found is that these skills are actually pretty interesting. Like they start to scale up. We start to create these sort of patterns and screens. And we can take these patterns and screens and in Design Studio start to experiment with them in different scales. You can see that we can start to mismatch patterning. But again, there was talk about this sort of idea of parametric design or procedural drawing or scripting or coding as a way to sort of generate patterning. You could always think about that, whether that's a flat screen, whether that's something that covers like I was showing before, a grid shell or something that's freeform. What I'd encourage you to do is think in terms of components and how they go together, right? Those details are really important. Like if you're limited in your the scale or the space that you're working in, or the size of the materials you have available to you, right? You can always think about making something larger from lots of smaller pieces. Okay, and so I think hopefully some of my work shows that, right? Like we're making these larger sort of immersive spatial interventions, but it's not like we're making something out of large materials. We're making lots of small materials, and then you add repetition to that, right? And that's where the modularity comes into play. You can then begin to sort of create something complex from something quite simple, right? Simple parts, simple rules, and you repeat a lot, can generate an enormous amount of complexity and enormous amounts of sort of richness and depth. And so don't let scale or complexity get in the way. There are ways to handle this. That's one of the ways that I've found that I've in my work that helps me sort of manage complexity and still, again, create something that is shippable, flat packable, fabricatable, and able to be assembled. What I find, I didn't include any examples, unfortunately, is to also don't be afraid to make drawings. Make the representation of how these things go together, right? Those assembly instructions, I think, can be quite lovely, quite beautiful. And in architecture, that's what we do. We create these representations to talk to others about how they're made. So at any rate, that is the wrap of my presentation. So thank you.
Thank you, Joshua sir. That was a wonderful presentation. I think the participants would have been inspired by your thought process as well as how you have fabricated each of the designs. We have some questions here we would like to take. One participant here asked, have you given a thought about how machine learning models can be integrated in some of the projects here that have been collecting digital data? For example, how can the infrared sensor data be applied to create automated systems for building services?
Yeah, I think that's a fascinating question. I don't have a good answer for that because some of these models are still relatively new to me. So when it comes to machine learning and AI, that space is moving so quickly. Even I'm trying to understand it better, but things are moving very fast. But yeah, I believe absolutely that we can start to make our built environments a lot smarter, and that big data and AI systems are going to help us sort of understand that information, aggregate that information, and help us understand what we can do with it. And that information might come locally at the building scale, the house scale, right? We now have smart thermostats and Internet of Things. So even our dwellings are more connected, but even at the urban scale. So I think about the information collected about weather. I think about the data collected by Google at bus stops and other public transportation infrastructure. I think about how cities collect information. I think there's a big interesting set of ideas out there on how cities can begin to leverage that information, or even just release that information to third parties that could then develop things to help make cities run better, right? Or to help us understand cities or buildings. When it comes to what I've done, where I sort of have these algorithms that sort of make things move in response to humans, I think that would be fascinating to sort of think about how it isn't just a sort of such a binary, it either moves or it doesn't move, but to actually try to make these systems smarter. It would take a lot more work, but I think that's where we're going, is how do we begin to integrate these AI models into what we do in order to make things help us better or learn from us, right? So if we thought about our buildings or, whatever it is, sort of learning about us and then customizing how they behave or react to environmental concerns based on our patterns, that can certainly be, I think there could be a value proposition there when it comes to performance, energy modeling, etc. I'm not sure if I hope that addressed your question, but it's a fascinating one. But I think we're just scratching the surface on where machine learning is going to take us with these diffusion models, and they can make interesting essays or interesting images. I do a lot of that where I'm just experimenting with these things, or help us write code, ChatGPT. But at the end of the day, I think the question is, how can these things actually enhance our built environments? And I think we're not quite there yet, but we will be soon, I hope. You're muted. Sorry.
Oh, sorry.
Yeah,
Yeah.
no worries.
Wonderful. Yeah. So we have few more questions. So one of them is while modeling, how do you deal with doubly curved surfaces, as doubly curved surfaces can be a problem while fabrication?
Yes. So first and foremost, the key thing is to identify why double curvature, right? So if there's either an aesthetic or a performative component to this, or spatial component to sort of reasoning to it, I think that's really important to identify, because you'll be fighting the double curvature a lot of the way. And so making sure that it's not something that can be removed is really important if you want to go further with it. So in this case, we're looking at structural performance and thinking about two-way system for a grid shell that could work, where the shell itself and its geometry is again, it's structural, and where double curvature can actually enhance that. So we were looking at shell structures. We were looking at other less architectural things, like, let's say, the body of an automobile or a plane, where they utilize double curvature in order to provide strength, to increase aerodynamics, and to enclose certain volumes on the inside. So, if you can justify it, you just got to make sure that value proposition is there, right? Like, there's a reason for it. Once you identify the reason for it, then it'll help you understand how you can create it without compromising it. So that said, there are a number of different ways you can think about this. You can try to take a very large block. It's not the most efficient way, and you can begin to carve it. You could do that to create the final form, or you could use that to create some sort of formwork that you could then slump or otherwise pour and cast material onto or within. Or you could do what we were doing, which was taking a doubly curved three-dimensional construct and breaking it up into planar components that could then be slotted and put in place with some sort of detail. In this case, we were looking at the model scale, so it's quite easy to sort of make these slots, and slot A goes into slot B just like that. Right. That doesn't necessarily work with every material, but it's something that would then have to just be detailed, right? And then you'd have to work out the tolerances, right? So making sure that you have everything dialed into how precise you can be and how precise you can't be, right? Certain materials can be very precise, and others you need that wiggle room and that play, right? So trying to understand how the detail can work with that, right? If you have everything in place and everything needs to be perfect, then it's really important that you have material that doesn't expand and contract too much with temperature and moisture. Some materials, all materials expand and contract with moisture and temperature, but some do it more and some do it less, right? There's also how those connections actually work mechanically, and do you have some play in them if you need to actually add room or subtract room in order to sort of put things together. So again, if you prototype these things, you can sort of work out the kinks as you go. And that's, again, what I think of is sort of thinking about, well, first of all, you have to think several steps ahead. But there's no substitution for just trying to make it, right? Make your ideas, try to make them. It's a challenge, but the sooner you pick up that challenge, the stronger your idea becomes, right? The more you start to understand what challenges are really there. So geometrically, we took the double curve shell, and we converted it into planar ribs, two-way system that could then be bent and then attached into place. So they had a little bit of wiggle room in their flat axis. Another way of doing that, we could tessellate it into panels that approximate some sort of curvature. You could think about it in terms of that park structure we did, where we had a bunch of triangles. You could actually make smaller triangles and then actually sort of approximate something that would be doubly curved, even if it's made out of planar triangles or something like that. So there's ways to do it. I guess the question is, what materials are going to use? How is it going to be used? Does it need to stand up to? What kind of weather does it need to withstand? Or what other kind of environmental concerns are there? What are the weight requirements? Are there going to be people sitting on it or walking underneath it or accidentally kicking it, right? A lot of times you can sort of figure out gravity, but then sometimes those lateral loads are the real tricky ones, right? You don't want it to shear over, or you don't want it to be a tripping hazard, etc. So lots of things to think about. Really good question.
Great, great. So we have a lot of questions actually. So let's go on one by one. So
Sure.
there is this question. I saw your social media pages that you have been exploring in AI. Can you speak about that and how and if you see it play a major role in design and fabrication?
Yes, right now it's just the role that it plays in how I see design and fabrication is at the very early stages, where I just have an idea and I want to test it out. And I can really quickly begin to describe what I want in plain language. And the diffusion model gives me really lovely images of what it thinks I wanted to see. It doesn't give me any three-dimensional information, doesn't give me any material information, although it does simulate materials and lighting and spatial atmospherics really interestingly. It has no idea what materials or atmospherics even are, right? So going back and forth with that is just a really quick and easy visual way to test some ideas before I get to the prototyping stage. But when it comes to actually making stuff, it's no substitution for actually just getting my hands dirty and looking at these things. So I've had students look at them over this past month or two. And ultimately what it comes down to is just getting our hands dirty, getting in the wood shop and getting access to some materials. Right now we're looking at one-time use plastics. So it's a really easy waste stream to hack and find free materials. Plastics continue to be an issue because many of them are recyclable but don't actually get recycled. And so trying to figure out ways to upcycle those while also getting a free material was a sort of value proposition that my students were up for. So that's what we're looking at right now. We were trying to study that through AI just to get some ideas, but it's kind of limited in its practical value. Once you get a few ideas in mind, you really just have to shift to what are the weight of these things and really trying to understand in detail how to put them together. And AI isn't quite there yet as far as being able to augment the production process. It can augment the sort of early conceptual ideas phase of design right now, but it doesn't really have an understanding of material or gravity or anything like that. So it's pretty limited. Another good question. Thanks. I appreciate that question a lot.
Great. So we have another one which says, can we make conceptual sketches and representative diagrams for this competition to explain our idea rather than well-detailed digital model due to complexity of design? I think Krishna sir, you could also team in to answer this.
I mean, Georgia should answer this because he's a juror. So he has to look into the design details.
Okay.
Yeah, I would say, the question isn't what is or isn't allowed. The question is, how best to represent your idea, right? So I think we could say yes or no to anything, but ultimately what's going to lead to success is how does that representation, however you're trying to do, either make a drawing or make a mock-up, a model, a prototype, whether it's physical, whether it's digital, right? How is that communicating your idea? And how is that telling us how you're thinking about the shape or the material or its performance, right? So that's a lot of hypotheticals with your question. I wouldn't be prescriptive. What I would say is ask yourself critically how best to represent these things. And if that means that you're using a computer and a mouse, or you're using an X-Acto knife and paper, or you're using pencil and pen, or you're writing computer code, right? Or all of the above, I'm all for it. I think the strength of the idea and how it's communicated counts. And I think each idea has difference, and so could be communicated differently. I hope that's a satisfactory answer. Feel free to supplement that if you need to. Yeah.
Definitely. So we have the same person asked another question. What do you suggest in terms of fabric as a material to envelop for our prototypes?
Okay, great question. I wouldn't say there's just one material. I wouldn't talk about fabric in a sort of monolithic way, because there are lots of different fabrics. So I guess the question is, A, what is it doing? B, how do you want it to perform? How do you want it to perform visually? How do you want it to perform potentially thermally? How do you want it to perform in terms of moisture? Does it need to be translucent? Does it need to be opaque? Does it need to have color? Does it need to be neutral? Does it need to be waterproof? Does it need to actually absorb water? Right. So it's not necessarily this one is better than the next one. The question, I think, really is, what are you trying to accomplish? Then I highly recommend going to manufacturers, ask good questions. Anybody that wants to try to sell you fabric will work to answer any questions you might have, right? So at that point, I would go to an expert, a company that makes these fabrics, and try to find the answers, right? But always have those performance criteria that you need, right? And that's what I would say. I didn't say that word, but performance criteria, I think, would be really important. I've done some things where we did portable shelters that sort of folded up, and the fabric became really important. And that's when I realized just how little I knew about fabric and how many different types of fabrics there are, and how many different ways there are to treat fabric. So if you're thinking about fabric, and you're not an expert on fabric, then it's incumbent on you to become an expert on the fabric that you need. And you'll have to talk to the manufacturers or the sellers or someone who is an expert in order to better understand that. But come with that performance criteria. Here's what I need. It needs to be foldable. It needs to be stretchable. It needs to withstand the weight of snow or whatever it is, right? Or it needs to withstand a certain number of daylight hours per year, however it works, right? To me, that's those performance criteria, that tells you exactly what kind of material, what kind of fabric you need. And really, the folks who work with fabrics all the time will be able to tell you then what might satisfy that criteria.
Great. There's one very interesting question. This is somebody asking, your background looks very interesting. What is it about?
Oh, it's just a quick white clay rendering model of a digital, just an aggregation of a very simple part, very simple planar unit that turns the corner 3 times. So it's basically a cube subtracted from a cube, and then it's repeated over and over again with certain rules about rotation and translation in X, Y, and Z to create a larger system that looks complex, even though it's made from a very simple part, repeated over and over again. Yeah, interesting question.
Then we have, what is your design process As in, how do you ideate and design and develop it further?
Yeah, so really quickly, I mean, I would say don't let the digital model become a crutch. Don't let the rendering become a crutch. Have a sketchbook with you. And then again, if you can begin to prototype these things, make, right? That'll tell you exactly right away how you go back and forth, right? If you can begin to understand some of the material constraints and logics with what you're using, and I realize you have you'll be using a wide array of materials. I think each of you will have something different. So, to me, the question then becomes, how does that become the generator? And how can you then begin to use those logics to help inform how you're digitally modeling or drawing your design ideas? So I work back and forth, but I think that feedback loop between your design and the material and production constraints becomes really important for this competition, right? It's not enough just to be able to visualize something really interesting. How do you make it? And how can making go back and inform the design decision making, right? So I think that's really important. I think that's one of the things that, if you have access to some of the tools, digital design and digital fabrication can help us with, is sort of speeding up that feedback loop. But that's what I do. We go back and forth. We make what we draw, and then we draw what we make. And reflexively going back and forth in a loop like that helps us develop with some real constraints, so that by the end we have something that we've made and we know we can make again.
That's wonderful. So we have another one where the participant is asking, how do you get the idea using robotics as a main element in design, which now has changed the whole perspective of enhancing modern architecture? Maybe I think they mean
so,
like the role of robotics in modern architecture.
right. So it's a really interesting question, and it's a really tough question, because like I said, buildings typically are designed not to move, or to move in very particular ways, based on thermal expansion, or what happens, unfortunately, if there's some sort of seismic activity, right? Then there's movement. But by and large, we try to make our buildings static. And thinking about robotics and responsive systems turns that on its head, right? So it's a very, very interesting but very challenging set of problems that you deal with when it comes to weight, inertia, gravity, even simple things like friction and dust and grime and grit that gets into mechanical gears and things like that become an issue when it comes to the building scale. So if you're interested in that kind of stuff, one of my mentors is Branko Klerevic. He has a book on robotic architecture, responsive architecture, that's really good. It's, I think, published by Routledge. So look up Branko Klerevic, and there's a really good resource on these things in that book. And a lot of leaders in that field wrote chapters in that book. So I recommend that as a resource if you're interested in sort of pursuing these sort of responsive systems and robotics and architecture, because you'll see a lot of different strategies, some retrofitting buildings like modernist buildings, others where they're building something new. And so, yeah, there's lots of different sort of scales that these things are being approached with. I work, when I've done these, it's been these sort of interior installations. So there's not too many architectural problems to deal with at one time. It's a really easy way to transform a space with this very small footprint, so to say. So that's how I've approached it with students, trying to get them to get introduced to these ideas. So.
Wonderful. So we have a very overall macro question, but also a very, okay, I will just ask it. Can parametric be incorporated into sustainable design? That's one question. And also, can you give us some insights about your teaching methodology to the students? This is the question.
Sure, absolutely. So as was said before in the first presentation, right? Like parametric design sometimes gets thrown around and refers to like some sort of weird doubly curved Zaha Hadid-esque geometries and aesthetics, but parametric design doesn't necessarily reflect any kind of one aesthetic or any type of geometry. It's parametric design is really about looking at the geometric properties of what you're doing and being able to adjust them. And so, yes, it's absolutely imperative that if we're going to address architecture, really looking at its environment and responding to it and building more sustainably, then parametric design is going to be a huge part of that, right? Parametric design allows us the freedom to sort of make repetition and difference. It allows us to respond to performance data and feed that data directly in to adjust the parameters of, let's say, a building facade or you know, some sort of high impact, high performance building envelope, or even simply experimenting initially with how we begin to site our projects, how we place them on the site relative to the sun, relative to wind patterns, etc. Right? So parametric design is a very rich space. If you think about ancient civilizations, they were doing parametric design before computation, right? So parametric design is very important. It's going to only increase in importance, but that helps us utilize real data, right? We can begin to simulate, let's say, solar information, solar energy. We can begin to simulate these sort of things and plug that data in to inform the parameters. That's key, right? And that's part of what we do, right? We do some of these weird shapes sometimes, and sometimes we do really normative shapes, you know, Euclidean geometries in school. But one of the things I try to make sure that my students come away with when I'm teaching parametric design is that there needs to be a reason, right? That the design, the logical underpinning of your design can be based largely on how whatever they're designing fits in and begins to respond to the environment, and how we can measure that response, right? So we can measure the environment, let's say solar radiation, daylighting factor, those sorts of things. And then we can use that data and plug it directly into their parametric grasshopper graph, right? So that's the key thing. That's the other feedback loop, right? So you can think about the design, your design ideas dealing with materials. They also have to deal with how those materials are put together. They also have to deal with how the thing that's put together will actually perform when it comes to sun, wind, and light. Also how it performs programmatically, how it performs culturally, how it performs as a piece of the larger urban infrastructure, whatever. So yeah, I mean, to me, parametric design is one of those things that helps us sort of negotiate and manage all of that information and utilize it in really smart ways. So absolutely. And that's what I hope the students come away with when I teach parametric design every year.
Wonderful. So we have a couple of more questions. One is, do you use any softwares to develop design and simulate the kinetic designs?
Right. I used to use like, you know, Maya or something like that, where I could animate with a keyframing to sort of simulate these things. I sometimes I'll try, but usually when it comes to that, it's developing the ideas mechanically. And oftentimes what I'll do is I'll try to find a system that already works, or I'll mock it up myself physically in order to really understand it. If you try to figure everything out in the digital space or in a drawing, sometimes things can look good on paper, but then in reality, they don't really work the way you think. So again, I would say if you really want something to kinetically work, then it's up to you to physically find how it works, right? Again, prototyping becomes the key because, you know, there's no substitute for just trying something out with gravity and inertia and pushing on it, or letting the wind blow it, or however you're approaching this stuff, right? And like I said, I mean, you know, when we first started this, doing this, we would sometimes, I would say, get stuck. And then we would get stuck basically having to throw money and more motor torque at the problem because we weren't working with the physics. You can work with the physics and begin to understand the mechanics and how you work with it rather than against it. It'll help you out. It also helps you figure out if, when, and how you can work with gravity. It's always easy if you can work with gravity rather than against it, right? So a lot of these things happen where you say, okay, well, I can wind this thing up, but then I have to wind it back. What if you wind it up, but then you let gravity do the wind back, right? So, you know, you can begin to, I think, experiment. And I think that's the key. I don't think it's not like you're trying everything all at once, trying to find happy accidents, but I think experimentation leads to just good design discoveries when it comes to thinking about how things move and how realistically you can accomplish that, right? You can really design a lot of science fiction in Rhino or any of these other platforms, but when it comes down to actually making them move in real life, there's no substitute for just trying to make them move in real life.
Right. So we have one last question before we move on to Krishna sir. Sir, can we use AI robotics with parametric design for room air conditioning and lighting? That's the question.
So yeah, I suppose so. I mean, you know, the question, I guess, is, you know, when I think about back when I practiced in architecture, right? A lot of those decisions were made based on the architecture, and it's basically mechanical engineers telling you what you need and what you don't need. But if there was some sort of interesting way that you were trying to interrogate, let's say, the lighting or the mechanical systems, air conditioning, air handling, then I suppose that could work. I mean, parametric design could certainly allow you to sort of test different strategies, perhaps, about how those things might be ran, and how they might perform. If you had some sort of performance modeling simulation software to sort of measure. I will say robotically, I mean, like sort of responsive systems, I mean, that these are the two areas where buildings are already sort of always been active systems, right? Like we have thermostats. So it gets too humid or too hot and the air conditioning kicks on, right? It gets too cold and the heater kicks on or the heat pump kicks on. And same with lighting. A lot of times now buildings can be retrofit with sensors to identify whether the room's being occupied, and if not, it'll turn off the lights for you in order to sort of decrease energy consumption, etc. So I'm not sure if I'm exactly answering your question or not, but I hope I've addressed it in a satisfactory way there.
Thank you, sir.
Thank you.
Krishna sir.
Joshua, that was, I think, an absolutely, I mean, very intellectual, very knowledgeable. I mean, so much amount of detailing that you spoke about, so much amount of design and plus the technical detail that you have spoken about. I think this session, since we have very less amount of time, I think we need to take one more session where you can seriously come up and discuss at large each and every individual project, so that people out here in India can seriously understand that in a much bigger way, so that we can really produce good things. So I think we need to have seriously one more session. So I hope let's do one more session, because this time we have got 3 panelists coming up, one after the other. So thanks a lot once again for so much amount of information that you have shared about the works, and also about how, as a teacher, you're trying to guide the students. So thanks once again.
Thank you.
I would like you to join the lecture as well. I think Subin is already here.
Yes, sir. Yes, sir.
Okay. Thanks a lot, Joshua.
Thanks again.
Thank you. Thank you.
Yeah, I'm looking forward to the next one. Yeah.
Yes.
So we move on with our event for the evening, and I would like to introduce our next speaker, architect Sumin Ham. She is the founder of Sumin Ham Design Limited, a London-based design studio focusing on design research and practice, tackling the issues of computational paradigm in architecture across multiple scales and perspectives. The research looks at ecology of computational power, technology, and human intuition, and sees how this collaboration impacts on design industry and the physical environment. The office approach is strongly academic driven and tries to bridge between academic interests and commercial practices. Currently, the office is interested in the use of augmented and virtual reality (AR/VR) to execute complex and precise digitally generated forms. Some of the research questions the studio grapples with are the future of humans, robots, machines, and computers in design and constructions. She's currently a design faculty of robotic researcher at SciArc, USA. She's also the director of AA Visiting School in Shenzhen, and she's also the founding director of Social Algorithm Research Group as a part of the AA Visiting School in Seoul. Welcome, ma'am. Welcome to this event, and I open the space for you to start your presentation.
Thank you for the introduction. All right. Hello, my name is Sumin. Thank you very much for the thorough introduction. Today, I'm going to talk about my project and research under the title of Augmented Architects. This is a short show reel from our practice. We are in general interested in the use of computer simulation, computer coding, appreciating the generated computational aesthetics, and using various methodologies to execute complex forms physically. And what you're seeing on the screens are various projects using this design philosophy, from student work to company projects. I'm going to skip this. And this is our team. And here are different projects, some built, some unbuilt, which I will explain more in detail later in this lecture. We are also sharing lots of tutorials online, organizing lots of workshops to meet young designers and architects. And as mentioned, in general, all of these interests are coming from appreciation of computer-generated geometries, really interested in using the help of technologies to inspire designers during design and making processes and affect the fundamental concept. And before going into more detail, I want to briefly talk about how we vision today and the future. I'm going to play this video.
Over the last 250 years, we've seen a lot of major disruptions as a result of technology. For the machine age, it was the steam engine and later the combustion engine, bringing on the end of the industrial age. For the atomic and space age, it was nuclear energy, taking men to the moon on these massive rockets. The digital age was all about computers, electronics, and in the later stages, the internet. But the next stage, the augmented age, is going to be about you and I and the way we live our lives. And over the next 15 to 20 years, almost every aspect of the way we live our daily life is set to change.
So basically, the author of this book, Augmented Age, argues that we are currently living in the age of augmentation, where devices and machines are closer to our bodies. Humans are no longer limited by their physicality. And just by using the smartphones, as our knowledge has been expanded, and we are already a cyborg. And we are no longer limited by physical limitations. And this fact challenges us to think about the relationship between humans and machines. And as today, the interface of machines is not limited to mouse and keyboards, and we can interact with machines so much more intuitively. And look at this fun video. And when a machine has no brain, and this happens. But ever since the breakthrough of AI alerted by the event of AlphaGo, so many things started to become possible, such as a car being smart enough to be able to drive. This has only happened possible recently because of the limitations of hardware that couldn't accommodate all these AI ideas before. But what is more? Such as this famous Atari game, to throw a ball to break the wall. AI, after certain iterations, AI found a creative solution to win the game. Let's have a look. After 500 games, so that's how the AI found a creative solution to beat the game really fast. Breaking through, digging a tunnel and breaking through to the back of the wall and using the bouncing to win the game. This is also an interesting example. These two AIs fighting. This red one couldn't beat the blue ones. But after certain iteration, red one found a really interesting solution by absolutely doing nothing and just fall down by itself, and then just scaring this blue character to beat the game. So this is about what I wanted to show and talk about is the creativity that we can expect from computer and AIs. Let me see what this person is saying.
As AI progresses, the great promise is that these machines alongside of us are able to think and imagine and see things in ways that we never have before, which means that maybe we have some kind of new, weird, seemingly implausible solution to climate change. Maybe we have some radically different approach to dealing with incurable cancers. The real practical and wonderful promise is that machines help us be more creative and use.
So as said, she believes and very positively believes that AI can help humanity to be more positive, more creative, and AI can potentially bring us unimaginative, creative solutions to our problems in humanity. Then what is the role of human? And this book, Human and Machine, offers an answer to this. And let's listen to this author.
For us today is what new types of jobs will AI create? Let's talk a bit about how AI can help people.
Forward this a little bit.
Percent of companies to work for is believe that their people are now ready to work with intelligent technology. So where should business and universities focus their training in the age of artificial intelligence? And here I'm going to offer a prediction to close that soft skills, that is your distinctive human capabilities that can complement an AI's capabilities, are going to be your source of differentiation, both in your career and your organization. Remember, as a human being, you are an infinitely reprogrammable imagination engine. So best wishes in achieving your natural potential in the age of artificial intelligence. And thank you very much.
So this author is offering that humans, that in any field, the the critical quality of leadership is to establish a harmonious and smart relationship between human and machine. Indeed, there are tasks where machines are much better than humans, but certainly there are tasks humans are much better than machines, and we need to find that niche. But every field has different types of workflow and framework, so it's everybody's responsible to establish their relationship and in any field of our lives. So with this in mind, I have been also thinking about these questions a lot. And I have practiced these thoughts in consideration of fabrication industry and thinking about how do we think about this within architectural discourse. And questioning what would be an ideal human-machine relationship in the digital fabrication industry, and questioning the way we approach labor in a more smarter way. And can we teach robots through gestures, for example, which normally takes humans for years to train to become a master? And this example was in a Bartlett PhD project, not my project, it's a reference. It's training the robot by actually carving and inputting this information and let the robot to kind of calculate what is the best carving passes, and the toolpath is not really like algorithmically written. It's generated through a lot of gesture training data based on the gestures. With many projects with students and researchers, we have been testing a lot of like materials and synthetic ways of making using this idea. And under the topic of augmented fabrication, we have tested various material processes to explore more meaningful ways to execute complex geometries and forms without constraining them with traditional 3D printer or CNC machines. And in 2019, with a group of friends, we built this pavilion titled Steampunk Pavilion. And this was a winning entry for Tallinn Biennale installation competition in 2019. And thanks to augmented fabrication, we could produce hundreds of all unique and different curvature with flexible mold system. Here's a more complete project video, which explains the entire process quite well. So I will just play this video for a while and hope you enjoy for the next around 1 minute. Okay. And next project I'm going to show is also, it's a gallery exhibition in SIAC, and it explains with the voiceover. The centerpiece of the exhibition has been built over the course of 3 months by SAR students and faculty. It is a design prototype of a fully functioning inhabitable space. The design is based on a fluid geometry where the curves travel around the three-dimensional spaces continuously, giving the audiences a unique visual experience. The traveling lines harmoniously combine all architectural elements into one whole, so there is no distinction between column, roof, or slabs. Curves loops back to provide structural stability as well as potential windows and door frames. The main structure is constituted of 2 parts: the steam bent timber and the fold bent metal brackets. The double layered condition allows the structure to accommodate potential infills, create proper enclosures such as insulation, envelope, and so on. The construction process was designed to bend multiple struts in one set of formwork for production efficiency. The formworks are set it up in a precise position by the help of augmented reality headsets. All metal bracket joints are also manually bent based on AR technology. Okay, I'm gonna fast forward some of these images. They are very similar, so. And then they were moved into the space, and there was an overlay of AR exhibition. That was the result. Yeah, and then the next project I'm gonna show. We have built a landscape project in Canada during the pandemic, and thanks to AR, we could communicate the entire building process completely remotely without the designers visiting the site. And it has been constructed by non-expert student volunteers, and construction supervision has been all done remotely through the cloud-based digital twin platform, as well as the augmented reality headsets. I'm going to fast forward, don't have to see all these details or prototypes, right? So this was the design, and this was the digital model that we sent to the construction crew. And our team has been spread all over the world. We had Korean team, we had people in London, we had people in LA. And every communication has to have been happening over Zoom. And these are the visions from the builders. They were our student volunteer. This device view. This was the some clips from the construction process. I say from around 6 entries, we were only non-local team that were selected to build this. Yeah, then maybe I'm gonna, yeah, so this is the digital twin. Let me just quickly show you how we were managing the supervision over the course of the of the period. So every single day they update the site conditions, and we could have compared that to the real digital model and give them supervisions. So this was the final result. And we also got a EPIC mega grant for this project. Yeah, and just finished last semester in a classroom context in SciArc, our students produced this chair using AR, exploring metal road bending and welding. So this is a student project, so just wanted to show you as well how we bring these kind of stuff also into the classroom context. So this was it's welding. If I can fast forward some of the clips. Yeah, so they added the steam bent pieces as more like decorative one from now. It's more like an additional secondary material. So this was a resulting chair. And another student project, same student, same class. They're very cute. They made a staircase. So same process using AR fabrication process, use AR to bend and use AR to weld. That's how they were welding. And then fast forward, a lot of welding and then finishing. Yeah, and then that's the result. And our next agenda is to explore integrating more precise robotics in AR fabrication process. And this is just an indication of what we want to do. We don't have much kind of finished or publishable work, but something, for example, we are very interested in gesture-based training robot toolpaths, or like this kind of projects as a reference. This is a robot holding the panel and human welds from the behind. So it's a very efficient ways of communicating or collaborating with human and machine, because machine has precision. Machine is much more precise, but humans are much more intuitive in terms of being able to deal with quite delicate and complex processes such as welding or screwing, hammering. So we are very interested in integrating this to our AR fabrication process. So, but we are in a quite infancy at the moment. We just started learning how to use this giant robot that SciArc just got recently. And we have been just testing various things to start from very simple stuff that we are looking forward to push a lot more to integrate with human machine kind of collaboration. And next, just a final few projects are just academic projects. Just want to indicate that we are not only interested in fabrication aspect, we are also very interested in foreseeing the development of technologies to affect our built environment and how in architectural design and urban scale. And many ideas have been tested within academic context, within classroom formats, and as competition entries from the practices. We just wanted to give you an idea what kind of things that we are also producing within academic or practical context. Yeah, and finally, all of our work can be found from our website. And all the links to our Instagram and Facebook can be found from our link. And we are also sharing lots of tutorials, and we call it SD platform. And we try to organize a lot of workshops and putting up an online context also on our YouTube channel under the name of SD platform, and trying to invite a lot of other external tutors to also teach. And so we can kind of collect different knowledges and intelligence within this platform for people to be able to search. Yeah, and this was my from me today. I shared everything what I wanted to. Thank you very much.
Thank you so much, ma'am. Hi. So we have a question we would like to take. This is a participant asking, as most of your projects is made by wood, can you share your experience of using it as a malleable product for your designs?
Using it as a malleable product? What does it mean?
I think they're just asking what the experience of how wood is as a material, and since you've used it a lot more, how I
think we chose wood as one of the generic architectural material. I'm not only interested in wood, and also because of this occasion that we won this competition in Tallinn, and their brief was about, like, we had to use wood. So that was kind of a necessity. And we found this steam bending processes, which was a really interesting challenge for us, because we didn't want to make straight, we just wanted to challenge also aesthetically. That's why we chose steam bending processes. So, I mean, I wouldn't say I'm an expert in wood. And also, I'm not really interested in only using wood, but I'm very interested in using architectural material. That's why I'm kind of avoiding using plastics, for example. Because choosing certain material in the beginning really affects the result, and also, if it's not an architectural material, you very quickly hit the wall in terms of scaling up. Yeah, but yeah, I don't know if I'm answering your question.
That's fine. There's another two more questions. How did you come across the possibility of using AR for fabrication?
Yeah. So in the earlier year before 2016, because AR HoloLens has been commercialized and we can buy it, even if it was expensive, we could start to buy and use it from 2016, not earlier than that. So it was not available. But before that, in school context, I have been with team of really great architects and designers. We have been working on a lot of material studies. And also we, just by some limitations of political situations in academia, we had limitations of accessing robots, and we have been always really being challenged of using machines. That's why really pushed us to work with different materials, and eventually we could have made a lot of material experiments for seeing some of the integrations with machineries. That really helped us to liberate us from using conventional robots or 3D printer or CNC machines. And starting to think about, because it was challenging when we have like these complex geometries coming from a computer coding or computer simulation, and we want to execute it, but the precision has been always the problem. That therefore, naturally, AR was one of our solutions to help us to bring the computer screen to real world and really helped us to work with our hands. But we have been already working with hands a lot. And it was very natural to bring extra devices to help us. So AR was not the reason why we do this in the beginning. It was for us to really, the goal was to really execute a complex form with more interesting, meaningful materials. Yeah.
So we have few more very interesting questions. One person asks, some of your work talks about human-machine collaboration and augmented workflows for the construction industry. How would latency issues of mixed reality headsets be a factor of accumulated error for actual construction? Had you run into some error while the fabrication and assembly of the steampunk pavilion?
Okay, so yeah, AR is not accurate. Also, anything you're making with hand is not accurate. So as you can see that our steampunk pavilion is curvy and like, it's fuzzy. It's not really precisely, the parts are not precisely related to each other. They're more like fuzzy relationship, but each parts are exactly the same. They are all same width and same thickness. And the choice of the design language was very important because this is actually coming from a lot of previous studies within school environment. We also tested a very straight geometries. Mostly AR-based fabrication didn't work very well with straight lines or certain geometry that requires very precise adjacencies. So we went about this problem by choosing certain design language that can accommodate these error tolerances. Such design language can tolerate much more imprecision. But of course, in the future, I'm also interested in, as I mentioned, interested in integrating more precise machines, like even 3D printer or currently robots. I feel like there are much more potential to go about this problem to improve the precision. So robot is much better in terms of producing parts. Humans are much better in assembling. And I think in a larger scale construction, this kind of relationship can be a lot more, brings a lot more potential and go about this unprecision and error issue.
Okay, great. So we have about 3 more questions. Since you have explored a lot on AR integrated fabrication techniques, do you see a possibility of integrating AI with AR to automate fabrication?
AR integrated fabrication. Also think with AI. Yeah, of course. Yeah, I think AI will help machines to be more intuitive, which means also like integrating AI will bring intelligence or making the machines more smarter. So for example, right now, if you run robots, they're brainless. They only like work based on your like pre-made toolpath, right? So it might clash with your table. It might clash with something. Like it's very dumb, right? But we foresee that AI will help improve these issues, so it can be more self decision making, being more environmentally sensible, being able to work with robot in real time. Like all of these are something we dream of in the future. Yeah, so definitely integrating AI is one of the key things that we have to integrate and we have to study.
So your project Steampunk Pavilion was executed with AR. Was it possible to build without AR or with 2D drawings? First.
I think it would have been impossible.
The next is, what is the simplest way to use AR right now without having the initial infrastructure at hand?
Initial infrastructure? Do you mean the devices?
Yeah, I think that's what they mean.
I see. You can use your phone. That's the easiest way to start. There are lots of free apps. We use Hologram. We were working together with Hologram. It's a free app for phone. You can try that.
Which headsets do you suggest for using AR?
We were using HoloLens, Microsoft HoloLens. I think that was one of the best clear vision AR. There are lots of AR devices, but there are camera-based AR and clear vision AR. So we were using Microsoft HoloLens.
We are so fortunate that you are a part of this competition. Is there anything in particular you're looking forward to from the participants in this competition?
I think I will see. I'm not the person to say this. Maybe I will see creativity, creative way of using materials, a creative way of using technologies. But probably just some like one really key idea that is very clear. I think that should do. It doesn't have to be like really complex, complete ideas with a lot of ideas. There most of the time, this kind of project needs one really good idea. So maybe find a strong keyword for your project. It's probably a key.
Thank you, ma'am, for the wonderful presentation and your
like
prompt reply.
Prithvi, I would like to ask a question, Suman.
Yes. So you can come on video.
Yeah, 1 minute. Yeah, hi, Suman. You said it was be impossible for you to execute the pavilion without AR. Why do you think so? I mean, it could have been even executed without the AR. That's what I feel. Now, why do you think that if AR wouldn't have been there, it would have been impossible to execute the pavilion that you have done?
Because it's complex. It's going to be so much more work if you were to do it without AR.
It would have been laborious, right?
Sorry?
It would have been a little laborious, but I think that project could have been executed even without AR. I mean, I was just thinking about it.
I would say it would have been very difficult. or wasting a lot of time. Let's say this using AR, we could have done this within certain that amount of time. If it was not AR, would have been stretched even longer.
Okay.
Sir, we have one question which I think even you could also answer. Since it's not, can we take the liberty to define the scale, location, and users for the installation? Is the question in the competition.
Well, I don't think that's my responsibility. Do we have site for this competition? I don't know.
Define the scale, location, and user of the installation. I didn't get that. What does that actually mean? Define the scale means, the scale has been precisely given. We have given the volume, the build volume at which they have to build it. So that's the scale. Location and the user for the installation, I don't think that will matter at all.
Yeah, that's more should be answered by the organization. No.
So I don't think location is something which is really important. Yes, scale is important because end of the day, we have to build the product. Build the design, whatever will be, whoever is the winner, we're going to build the product, right? So the scale will seriously matter. But location and the installation of the place, of course it won't. So it's all hypothetical. You can think of something else. You can think of any location, any design. It would be better if it is functional. Of course, if it is an art or it is a sculpture, most welcome. No problem at all. End of the day, it is all the jurors' responsibility to examine the drawings and the details that you guys are going to produce. I hope it has been answered.
Yes. Thank you, ma'am. Thank you for presenting. Sir, would you want to?
I seriously thank her to come on board. It's too early for her at this given period of time. I had to call her twice to make her wake up in the morning. I'm extremely sorry for that. Okay,
thank you for having me.
Thanks a lot, and hope to see you soon in India.
Thank you.
Thanks a lot.
Thank you. Bye.
Thank you, guys. Thank you for patiently watching and learning with us. Please do send in your entries for the competition and encourage other people to also to attend the competition. Thank you so much. Thank you for it.
Prithvi, I would like to tell something to the participants as well. See, the registration is still open till May 22nd. People can still register. We have been sending across the the IDs to them. So no worries at all. You can tell all the friends of yours, whoever wants to participate, they can still register. So the registration link is still open till 22nd May, and 22nd May is also your submission date. So thanks to you all again, once again. I thank Suman, Joshua, and Raj for coming up today and seriously enlightening everyone. So great. Thanks a lot. Bye-bye. See you all. Have a great day.
Thank you for this wonderful session.